Good evening, geometry students. We are continuing in chapter 9. We're still working on sections 1, 2, and 3. We're in day 2, not section 4. My apologies. And what I'd like you to be able to do is to give detailed descriptions of rigid motions of shapes in the coordinate plane by the end of this lesson. So basically, I don't want you to just say, slide the shape or reflect the shape. I want you to be more specific with it. I want you to be able to say translate and then write a translation rule. What did we do in that particular situation? But I'm still going to write just, some reminders in here for you. So writing rules, for example, we have all these shorthand things in geometry, like we know, just for a quick example, we know that symbol means congruency, right? So instead of writing all of the words out, translate triangle, ABC, yada, 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 or whatever, we have a shorthand for that as well. So we're going to talk about that shorthand today. So translations, just to remind you, that means to slide a shape. And it says how we write it. So how are we going to write 6 units to the right and 4 units down if we want to move point A, and this has nothing to do with the graph, this is just some example. If we want to move point A, which is at 2, 2, 6 units right and 4 units down. Well, this is a translation, so a capital T is going to represent translation. Now we need to describe how that translation is going to work. So at the bottom right-hand corner of that T, I'm going to put these little kind of pointy brackets. They kind of look like the head of an arrow. And I'm going to describe what's going to happen in that translation. So this works kind of like X and Y. So if you're moving to the right, then that would be positive 6, and that would be an X change. So I'm going to put 6. And then how is the Y changing? How is it changing from up and down? So it says 4 units down, so I'm going to put -4 after that. And then I'm going to close my kind of pointy bracket right there. Okay, so what this is saying is translate 6 right and 4 down, but translate what? So that's my next thing. Translate 6 right and 4 down, the point 2, 2. So that's how we write that rule right there. Okay, what if we wanted to say to translate 8 units left and 0 units up of triangle PIG? So I'm still using capital T for translate, but how am I going to translate? Where do I want it to go? So 8 units to the left, because it's going to the left, that's going in a negative direction, so I'm going to say -8, comma, and then if it's going no units up or down, it's going to be comma 0. Close your pointy grouping symbol right there. But what are we translating 8 to the left and 0 up? Well, we're translating this triangle PIG. And there we have it. Let's do one more. We want to translate 1 unit left and 3 units down of point H, which is at 5, -1. So I'm going to put capital T. And then how am I translating it? So the bottom right-hand corner of that T is the actual translation rule. So 1 unit left is going to be -1. 3 units down is -3. Close that. And now I'm going to put my coordinate that I'm actually moving in that direction, which is 5, -1. You can also put H, like if you weren't given a coordinate, like maybe it just said 1 unit left and 3 units down, H. Then you could put H in that position as well. Can we also write a rule if we have an image? So let's look and see what happened here. There's lots of ways to figure out what this translation rule is, but we started with this triangle and then we went down here. We know it went from here to here because of our A prime, B prime, and C prime. And remember that prime is indicating what the new shape is. And these are not exponents. That's kind of like an apostrophe. So we can just count. We know that a translation should be the same for each point. So we can just count on here how far down we went and how far over. So I'll just go from C to C prime. So C to C prime is down 1, 2, 3, 4, 5, 6, 7, 8, 9. So down 9, we're right here, and I'm just going to put that over here to the side real fast. And then right 1, 2, 3, 4. 1, 2, 3, 4. Right 4. Okay, so just keep in mind that whenever you count this, you're going to put the X rule first and then the Y rule next, because it's kind of like X and Y coordinates. It's not a coordinate, but we put it in that order. Okay, so what are we doing to triangle ABC? Well, we are translating it. How are we translating it? So that's going in these pointy brackets down here. We moved it to the right 4, and then we moved it down 9. And what was it that we were moving? We were moving triangle ABC. And that's how we write the rules for translations. So if you see a problem that just says, I don't know, T6 negative 4 triangle ABC, well, you're going to know, okay, based off of wherever your triangle is, move it 6 to the right and 4 down. So that's how you would read those directions and then follow through with it as well. Okay, reflections. Reflections, that kind of equivalent word for that is going to be flip. We flip something over a line. So, just like there was a capital T that represented translate, for reflection, we're going to have a capital R that represents reflect. And just like with the reflect, I need to know where I'm reflecting, or about what line am I reflecting this. So we're going to indicate the line that this is getting reflected across. So it says reflect triangle PIG across the x-axis. So this says reflect, but reflect where? On the bottom right-hand corner of the R, I'm going to put x-axis. Okay, what am I reflecting? I'm reflecting triangle PIG. So same concept as above, it's just now we have an R and we're indicating what we're reflecting across rather than how far over or down or whatever we're moving it. Okay, this one says reflect point M, which is at 8, 2.5, about line K. Okay, don't be concerned about where line K is. All we know is that it is line K, so we're going to have an R for reflect. What are we reflecting it across? We're reflecting it across line K. But what are we reflecting across line K? So it says this, so far this says reflect across line K, but what? We are going to reflect the point 8, 2.5. Let's do one more. We want to reflect triangle ROT about the line x equals y, or sorry, y equals x. So we have our capital R. We want to reflect it across the line y equals x. So this says reflect across y equals x, but what are we reflecting? This triangle right here, triangle ROT. Now, we have a special type of example right here. This says reflect the polygon across x equals 2. So far, the only thing that you've done is reflect across an axis. But what happens when you reflect maybe across a line that's up here or down here or way over here? So first, we need to identify where x equals 2 is. When x is equal to a number, this is going to be a vertical line going through x equals 2. So my suggestion is to kind of mark on that page where that is. So if x equals 2, that vertical line, that's my line of reflection, is right here. It is not your axis. You can reflect across any line you want. And in this case, we're reflecting here. So remember, you have to keep your coordinates the same distance away from that line. And I'm going to make sure that I'm labeling each one as well. So I'll just start at V and work my way around. V is on the right side of this green line, and it is 2 away. So to do V prime, I need it to be 2 away on the left side. And I'm going to label it V prime. And then I'll just start working my way around. D is 1 away on the left side of the green line, so it needs to be 1 away on the right side of the green line. So here is D prime. Okay. Now I'm going to A. A is 1, 2, 3, 4, 5 away from the green line. Do not stop at the y-axis. We're not reflecting across the y-axis. We're reflecting across the green line. So 1, 2, 3, 4, 5. If it's on the left 5 units, then now it needs to be on the right 5 units. 1, 2, 3, 4, 5. It's where this E is right now, but that's okay. That's going to be A prime. Let's keep going around the shape. B is 1, 2, 3, 4, 5 away. So since B is 5 away on the left side, it now needs to be 5 away on the right side of this line of reflection. So 1, 2, 3, 4, 5. Here is my B prime. Continuing to work my way around the shape, now I have R. R is on the right side by 1 unit, so now it's going to be on the left side by 1 unit. And then E is 1, 2, 3, 4, 5 away, and it's on the right side. So now it's going to be 1, 2, 3, 4, 5 away over here. So E prime. What makes this a little tough for people is how much it overlaps, and sometimes that gets them confused. So just take it slow and do one part at a time. So now we're just going to connect our vertices. Let's see here. V prime needs to go to D prime. D prime needs to go to A prime. A is going to go to B. B is going to R, or R prime, I should say. And R is going up to E prime. And then E is coming back up here to V. So let me highlight that in this pink marker so you can see it just a little bit better. So that pink image is the image of this problem, while the gray one is the pre-image. So we're able to reflect across any line that we want, just like I said. And just so you can be reminded, if y equals a number, that's going to be horizontal. Like it'll be a horizontal line that you reflect across. If x equals a number, then it's going to be a vertical line. And we've covered that a lot, but that's just kind of review for you. Okay. Finally, we have writing rules of rotations. So here it says, how do you write it? So we can't use R again because we've already used R for reflections. So we're going to have to use a different letter. For rotations, we're going to use the word Q, or the letter Q, I apologize. So this says, rotate triangle BUI 90 degrees about point P. So we're going to put Q. Q means rotate. We still need a rule of how to rotate, though. This says 90 degrees about point P. So I'm going to put 90 degrees, comma, P. So that's letting us know rotate 90 degrees about point P. I will say before I totally forget, so, rotations are when you turn a shape. But also, unless it's stated otherwise, so I'll just put this over here in the margin real fast. Unless stated otherwise, rotate counterclockwise. So it's going to tell you clockwise, and if it just says rotate, and there's like no counterclockwise or clockwise or whatever, then assume that it's counterclockwise. Okay, sorry about that, kind of a little side note. So we're rotating 90 degrees counterclockwise because it doesn't tell us any different about point P, but what are we rotating? We are rotating triangle BUY. You can also rotate segments such as segment AB, and I don't have a marker here, but whatever. Okay, so it says rotate line segment AB 180 degrees about the origin. Okay, so I'm going to put Q because Q means rotate. Now I need to put my kind of directions for how to rotate. I'm going to rotate 180 about the origin. You're able to put an O, make sure it looks like an O and not a 0. An O can represent origin for us. and actually, we're always going to be rotating around the origin from this point on. And then what are we rotating 100 degrees about point O? Well, we're rotating segment AB. And that's how you're going to write that rule. Now, here we have a little table. I'm not going to go through everything with you, but this is just giving you kind of like a cheat sheet for the rules. So it says to rotate a point 90 degrees counterclockwise about the origin, you can follow this rule. So if you were at XY, 90 degrees counterclockwise is going to change it to negative YX. And you can just plug in your values and just kind of follow these formulas for any one that you end up doing. So I'm actually going to highlight what I consider to be the most important parts of this table. And you can go back and, like on quizzes or tests, because you know they're open notes, you can use these as reference. Okay, we've got 2 rotation problems, and then we are done with this set of notes. So it says rotate the image 90 degrees counterclockwise about the origin. I accidentally wrote the word counterclockwise more than once here. Okay, so rotate the image 90 degrees counterclockwise about the origin. So what we can do, we can kind of consider this shape and what's happening to it when it's going counterclockwise. It's going boom, 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 boom. It's rotating up that way, okay? So let me see if I have a paper in here. Hold on. I am going to do my best to get a little artistic for you guys. Okay. So here is our trapezoid that we're going to be rotating counterclockwise. If this gets rotated up here 90 degrees, it's going this way, this way, this way, this way. Notice how it's changing kind of orientation when I do that. Now the narrow part right here would be more narrow than up there is pointing to the right. And it's 1 unit away from this axis. So when I move it up, it needs to remain 1 unit away from that axis. So this corner right here is coming there, while this corner is rotating to here. This corner right here is rotating around to this guy. I believe 1, 2, 3, yeah, right there. And then this one is going to be rotating around to here. Connect your coordinates, and you're good to go. Now, you're also able to use your formula up here. You can say, okay, what are all of my coordinates? So this guy is at 2, 1. This one is at 4, 1. Whoops, sorry you guys, can't see what I'm writing. This coordinate is at 1, 4. And this coordinate is at 5, 4. And it said rotate 90 degrees counterclockwise. So then, if these are my X and Y's, and I know the rule for 90 degree rotation is negative YX, well, I can just fill that in to my coordinates now. So I flip the order and then make the Y negative. So this would become, so I flip the order, 1, 2, and then make the Y negative. Flip the order, 1, 4, make the first negative. This would be 4, 1. And 4, 5, making that first negative. I'm following the rule from the table up here in the notes. Okay, we can do that same thing with rotating the image 207 degrees about the origin. We're doing this counterclockwise again. So I will do this via the table rules just so you can see that again. So I'm going to write this up here. A is at 1, 2, 3, negative 3, 1, 2, 3, 4. 4. So negative 3, 4 is where A currently is. B is at 2, 7. C is at 6, 4. And D is at 2, 1. Now, what happens when I rotate them 270 degrees? So look at your rule. Your rule for 270 degrees is going to become y, comma, negative x. So it's going to be opposite of whatever the current x is. So I'll write these in a different color for you. I'm going to change the order. 4, negative 3, and then change the sign on the x. So this is going to become positive 3. Change the order again, 7, 2, make the x negative. Change the order for, and then I'm going to go ahead and make that 6 negative. Change the order with a negative 2. So I am following the rule that I was given in the table for 270 degrees counterclockwise. So now you can just say, oh, okay, A is at 4, 3. So let's do that. A is at 4, 3 over 4, 1, 2, 3. So A prime is right here. B is at 7, negative 2. 7, negative 2. There's B prime. C is at 4, negative 6. 1, 2, 3, 4, 5, 6. And then D is at 1, negative 2. Connect your vertices. I will highlight it a little bit for you so you know which one is which. The highlighted is the image, and I'll do that over here too real fast. And there you have it. You got your rotations done. All right, that's all for notes today. For a closer look of transformations, have a great night, and I hope to see you in class soon.